We are going to discuss the approach to the solution to the maze problem that we have already described, and we have also seen demos of how our code should work in order to find the solution. After we have given several hints and we have discussed extensively our approach, you can go ahead and develop your solution. First of all, we will regard the maze as a matrix of characters, a two-dimensional matrix. After we have read the text file into the two-dimensional character matrix, we will also identify inside that matrix the start and the end locations. After this initial setup, all we will do is call the solve method, which, as you probably expect from previous discussions that we had with recursive methods, the solve method will be the proxy method that will get us started. It will return true if a solution exists in that particular maze. It will return false if no solution exists. But it will not be the method that will be doing most of the work. To do the work, it will call the recursive method that will take as arguments the starting row and column. So this will be the private method, the recursive method that will actually be doing the work. Now, if a solution does exist, we want it to be marked in the maze array as a series of star characters, as we have already seen at the demos. Let's now delve into the actual interesting part, which is the recursive solve method. The solve method obviously will have to start from where the argument tells it, from the location row and column in the maze. Now, since someone has called solve with that particular row and column, the method is going to assume that a series of stars are in the maze already and are leading up to this location. So at least one of its neighbors will have a star. We will start, before we talk about the base case and the recursive case, we will first check the special cases, which are we standing on a wall? Are we on an existing path that we should not investigate? Are we at the end location, which is the only happy event, the only event in which we should return true? In the previous two cases, we're just returning false. Now, once those special cases are done, we will put an asterisk, a mark to this particular row and column location, so that we ensure that the final path is identified. This practice will also prevent us from looping back onto the same path. Now, if we reach a dead end, if the current location, row, comma, column, does not lead to the end of the maze, then we will have to remove the mark and reset it to space and then return false. You may have noticed that I mentioned that we are going to check whether we stand on a wall, for example. Since we are not in a physical maze, it is okay to first move and then ask questions like, are we outside the maze or on a wall or on an existing path? This is a flexibility we have since we are just writing a program and we're not in a physical maze. What are the failure cases again? Whether we have moved outside the maze, whether we are standing on a wall or we're standing on an existing path location. What is the base case? The base case is the one where the current location is the end location, is the end of the maze. And of course, in that case, we will return true. What are the recursive cases? We already said that we're going to mark the current square as on the path, as if it is on the path that leads outside of the maze. And then we're going to call recursively solve on all the adjacent locations to see if we can get to the end from any of our neighbors. If any of them returns true, then our recursive method is going to return true to our caller. There was success, we found the end of the maze through this particular row, column location. Otherwise, if our recursive solve calls return false, then this particular location does not lead to the end of the maze, so we're going to unmark the current square, we no longer want to go that way, and we will also return false. This is a picture showing what we described. The X, the red X, is where we stand, and then we want to investigate all of the cases, going up, down, right, or left, so that we ensure that we investigate all the paths that may lead out of the maze. Now, with this description of our approach to the solution, we can go ahead and implement the solution. So I ask you to pause the video again, implement the solution to the maze problem, and then come back and see the discussion on it. We're going to see together the recursive solve method, the code for the solve method, the actual code that solves the maze as a whole is longer, and you can consult it on your own. You have the file for it. But the most interesting part, the recursive part, is the solve method. As we already said, the first thing we do is handle all the special cases. Are we out of bounds? Are we on a wall? Are we at a part that we have already investigated with the star? If this is a case, return false. Otherwise, keep going and mark this location as if it is on the path. Mark it with a star. Why is this a thing we want to do? Because later when we go and do the recursive calls, the recursive cases, those calls will be assuming again that there is a path that led them there, so that one of their neighbors has a star. So it is good to put the star before we make the recursive call, instead of waiting whether the recursive cases are going to return true and then mark the particular location with a star. So we will first mark the location as on the path. We will check the base cases, the happy case, if we are done. And then, if this is not the end of the maze, we're going to try the surrounding spaces, all of our neighbors. If one of them returns true, then our method is going to return true and we will all be happy. Otherwise, we're going to unmark this location. We're going to backtrack. So this is not a location through which we can go to the end of the maze. And we will also return false, so that this location, this path, is not followed.